Hi guys. I don't know whether it's streaming or not right now. It's something looking off. By the way, welcome to High Entropy and it's weekend and it's grind. I'm little late or very late to be honest because I was working. Uh, I had to I had to raise one PR, so I was working on that. And second thing, I started scrolling reel and it's very addictive. Reel or shorts you can say because I was scrolling on YouTube. By the way, let's begin and we are going to solve some DSA problems. And today I'm planning to solve plenty of exam problems. I'm planning to revise. First, I will try to solve two graph problems. Woohoo! And then we'll see. So let me transition screen. And if you have any questions, do let me know. Maybe I'll check where I should check. I am actually iPad I'm using for I don't know. I'm not tracking the charts that properly. By the way, no one is gonna being given. So let's begin. Begin. Oh, why do I open YouTube? I don't know. Sometimes I do some stupid things. Graph. Okay. So okay, where is my 1 minute, guys? Fuck. Today I'm sitting on bed. Weekends I thought to use a different setup. That's why. Okay, no problem. We'll start. It's raw stream. I became addictive of sorts and reels. I need to stop it anyhow. I feel bad about it. God. So, first thing, let's take one example. What is the topic of it? Shortest path algorithm, shortest path algo, and problems. So we are using this desktop. No, it's a Dijkstra. Hmm, hmm, hmm. Hmm, hmm, hmm. Minimum multiplications to reach end. Okay, multiplication. That means there will be h's and we need to multiply. I am just assuming. Given start, end, and an array of n numbers, each step the start is multiplied by another number in the array and then a mod operation with what the heck? Given start, end, and an array of n numbers. At each step, the start the start is multiplied by any number in the array. Okay, you are multiplying start with any number in the array, and then a mod operation with what is number of 2 10 to the power 5 is done to get a new start. Find the minimum step in which the end can be achieved, starting from start. If it is not possible to reach the end, then return -1. Cool. We want to reach from start to end. How can I get it? What exactly needs to be done? Bro, this problem I feel like I never thought in terms of graph. Even right now, I have to think in the graph's point of view. But if I'll get this problem, then definitely I will think, okay, I need to iterate or I need to do something to get this value, blah blah blah. But let's do one thing. Let's do some uh, analysis. What we say. अमेरिका क्या कहता है कहता था sorry I just I'm just trying to be funny, but I'm not, to be honest. I'm very serious person. Person, you know, if anyone is watching. Given start in an array of n numbers, at each step the start is multiplied by any number in the array. First, let's see what is the length of range of numbers in the array. N can be 10 to the power 4 at max, and array will be having n numbers. Okay, a number array of I can be up to 10 to the power 4, 1 to 10 to the power 4. Wonderful. Now the next thing is we need to 10 to the power 5. We need to divide. Start. Uh, okay, there will be something from it, right? Okay, 10 to the power 5, and you have numbers. That means, okay, sorry. Where is it? Yeah. So we have given numbers. Every time you are going to divide the number. Okay, 1 minute. Imagine you have 257 and array start is equals to 3, end is equals to 10. So what can we do? And 10 to the power 5 mod. So all the numbers should be lesser than, that means star end should be less than 10 to the power 5, obviously. Start greater than 1, and start can be 10 to less than 10 to power 5, because modulo if you are taking always it's going to give return the value less than 10 to the power 5. Imagine these are the numbers. Start is 3. So what can we do? 3. That means let's first run it, how it's going to work. So if you have 3, you want to reach 10, you want to reach in minimum number of step, and what exactly we are doing? At each step the start is multiplied by any number in the array, and then and then a mod operation is minimum multiplication required to reach to the end. What's the point here? Something is, if the number is bigger than this, why don't I mod divide? No, number will be lesser than this. What's the meaning of it? If I'll do 3 to the 6, 6 by 10 to the power 5, 6 you will get, and 3 5s are 15, so 15 will be bigger than this, so you want to. So first, let's say you did 3, 2 the 6, 6 by 10 to the power 5, so you will get the 6 only. 6 will be start, and now again you can multiply it with any numbers. We won't get. Oh, okay. End can be achieved? Are you crazy? It's like you are reaching out of end. Oh, sorry. End is 30. Fuck. I was thinking 10. 6 5 are 30. Okay. And another example 3 4 6 5 65. Start 7 end 66175. Where is it? My 66175. Start end 66175. So what I'll do, simply start, simply end, and I need a bigger number, right? How do you calculate it? 65 into 7, something like you will do. I'm not. Algorithm is not clicking into my mind. We have start, we have end. How to decide like what to choose? For example, if there is something, where is hidden graph? You are starting from start is 7, end is 66175. These are the two nodes we can see. Every time, what exactly you are doing? From 7, you can reach here, you can reach here, you can reach here. 7 threes are 21, 28, and 765. These are the notes that you can reach. 765 into 7. Okay. From here, now you can again say you have three options. You can go to any node if reachable. Correct? I mean, yeah, you can say again it is 21 kissed into 3, and this, all the nodes. So you will continue to do this. Is it right? And then what you'll do, you can say I'm reach going from 7 to 121. From here you can, whether you are able to reach, and you will find. Okay, I'm just thinking, can we do in such a way? What will be the number of all the are the numbers different? N numbers. It is like you have to explore all the different possibilities from start. So what you'll do is start from start only. You'll start multiplying these numbers. Then again, for each node you will start multiplying again with these numbers, and could be 10 to the power 4 here. Very bad idea. Approach. Yes, I don't think this is the right approach where you are exploring all the possibilities, then you are checking whether 66175 you can reach. Not sure, but still I feel, suppose here you got something and all numbers are less than this, so you will, what you will do, you will multiply all the numbers with this uh, start. So there will be 10 to the power 4 edges between this, and for each node then again it will be like 10 to the power 4 can be max, 10 to the power 4, 10 to the power 4, and it can go up to 10 to the power 4, 10 to the power 5. So 10 to the power 5. I'm just assuming all the possibilities that you are getting from here. If you are applying all the 10 to the power 4 again, so it will be like, how do we calculate? Every time it's like 10 to the power 4. First we got 10 to the power 4 into 10 to the power 4. Fuck you. It's not a right approach. For sure. I'm damn sure. Damn sure. Then what should I do? Given a start and end and an array of an integers, each step at each step the start is multiplied by any number in the array, and then a mod operation with, it's like you are building adjacency and then you are exploring all the paths, and from where will, okay, let's imagine if you did this, you are able to build this, or even you don't need somehow, maybe how. First thing is whether we are able to achieve this. Crazy. I don't know why, but I feel like I need to watch tutorial for this. Crazy. One thing I will do. What I'll do? Okay. First I will start clock. I feel like, no. Let's stop it, bro. I don't need clock. I need something else. Still, I'm feeling like I should try. Given a start in an and an array of n and t numbers, at each step the start is multiplied by any number in the array, and then the mod operation with 10, 10 no, 100,000 is done to get the new start. So every time you are getting new start will explore all the options from this array. So if I just, let's assume you are at 7. Okay, you are at 7. What you did, simply you started uh, adding these items into the queue. So you added 7. Now you have all the different options, so you will check between these options, and let's say if all of them are possible. No, yeah. Okay, I think I'm not getting. Let me take first hint. Use a queue where each entry contains current value, step taken. Crazy. Use a queue. But why? I'm not getting. Every time I'm making a number, given a start, intent, and array of n numbers, at each step, the start is multiplied by any number in the array. And then a mode operation with every time I start is use a queue where each entry contains current value and step taken. Current value and step taken so far. So if you are somewhere, process each number, generate new number current into num. Q exit. If Q is exhausted, okay, that means you finished. Return minus one. Is it like uh, you are saying every time I will pass the current number and steps will help us. Now you will generate all the numbers corresponding to it, and let's say there are 1 2 3 in the array. 7 2. Okay, let's say you took 7 and then no, not 7, I mean, yeah, so 7 again and step 1. Okay, so you are multiplying with 7 and then you are taking modulo, and then again 2 7 2 are 20, no, 14 14 1 and another 21 1. And what we'll do, we will maintain a number array num where a number will represent, suppose 7. 7 for 7, what is the modulo, what is the steps, and if you are getting minimum step from somewhere, let's say you processed 7 first, again you are getting somewhere 7, and then you will say, okay, if you are getting a smaller number, then 7 1, that means you already took simple number, smaller number, then you won't process it. Another 14 1 you haven't took, so you will process it. 14 1 whether it's possible or not. 21 1 you will process it. If it is smaller than number, then you will again explore all the possible combination. but I don't know. I feel won't it take lot of time to process the numbers? I think I will get really values. I'm not sure about it. It's a very confusing question. What I'll do? Uh, First, let me think more. How to make sure? Okay, if something is wasted, can we say the result was better? Cannot say. 1 minute. I will do in such a way. Suppose you are getting some numbers, so you are writing all the labels one, and again now you are processing another label. So if something has already been wasted, that means then after that you are wasting again. So for example, suppose here one we have 7 a, then 7, 14 and 21. These are the numbers generated by 7 multiplying by 1, 2, 3. Now you are again wasting 7. That means you already got something better from here. Let's say again you are getting, so in the level 1 you already processed it and you got minimum. If something is wasted, then you are again expanding the steps only. So I, I'm not feeling confident that I have that approach is working, but still I can try. So we don't need heap q, we need simply q, and I forgot the q. Fuck, what I was using. Stack for that I was using. Yeah, I remember. We don't have q directly, so we were using heap q. No, priority q. No, dq, tick. Sorry, tick. So this is one of the this is our q. Result will be, what are the number of nodes? Not nodes, but you can say result constraints 10 to power 5. So int will be less than 10 to power 5. So do I need till 10 to the power 5, or till end only? If number is greater than that end, simply we can ignore that number because we cannot get from there. So okay, so for 0 for underscore in range end bro, sorry. It's not result, by the way, it's visited, I can say. And for 0, Okay, visited of 0 I will mark 1. Okay, so first thing, dq dot push left, push left, right, left, push right, left, right, left, right, left, right. I think dq dot append, and here we will append simply because last at the end, pop left, append, yeah. So here we are going to append start, and value is nothing but 0. Okay, and also mark visited of uh, start is equals to 1. Perfect. So while dq, so we are just checking whether until there are items in the dq. So we will do one thing, node, I'm just calling it as a node, and what is the name of it, steps is equals to dq dot pop left. So here we are taking out from the dq, we got node, I will number, yeah, or we can say, sorry, start. So if somewhere in between you are getting start, if start equals to end, then return what, return steps, else we need to process it and at the end return -1, because if you are not able to get, otherwise what you will do simply, if it is not the case, then uh, start you got for num in array, and for each num what you will do, simply you will get new start, ns new start will be something, I will set it here mod 10 raised to the power 5, 5 only, right, 3 to 5, perfect. So new number will be start, that you will you say into num modulo what. Okay, one thing, I cannot blindly 10 to less than, start will be less than 10 to the power 5 steps. Okay, every time whatever you start you are getting, so yeah, number will be 10 to the power 5 less than 5, 10 to the power 5, so 10 mod. Okay, it's okay. So we got ns new start, this will be, and there could be multiple, if not visited ns, then simply append, okay, q dq dot append ns. Okay, one more thing do, first mark visited ns equals to 1, and append two things, first thing new start, and another thing label step plus 1, steps plus 1, because the count is increasing every time you are performing new operation, and that's why. Unexpected I indent, what the, where is the issue, text itself is not okay or what. Where is the issue? God, fuck. From this is the problem. From collections, not collection. Unexpected indent. This is big problem. Line 10. Is it this one only or is there anyone anywhere else? What's wrong? Something. Okay, let's do one thing. Is it just because of indentation or I'm wondering. While where is the exact issue? It's crazy. List index. Wait a minute, bro. Ah, okay, okay. One more thing. NS less than equals to end. Oh, I just went end plus one. Sorry. First thing. And another thing is we need to check if you are getting less than equals to end. Crazy desperation. Where are you? Tararam, tararam. Delete, delete, delete. Time limit exceeded. Sit. Oh, What is expected value? Oh, okay. Start equals to. What is the expected for it? Hmm. For sure, definitely you cannot get it in zero. And second thing, if you wanted to get the end lesser than the start, is it possible? I mean, every time you are going to multiply a number, suppose 664, 654, if you will multiply with some number, definitely number will be bigger than this number. And oh, just let me do one thing. Can it be? Will it be possible? Start is something like 10 and 3. That is okay. 3 start is 10. Now suppose there are numbers like 1, 1, 2, 3. Any number it will be bigger than the number. You will take modulo. So it will be 10 to the power 5 less than 10 to the power 5. I think, yeah. Start less than uh, greater than end greater than minus 1. What you did? Start greater than end. Okay, you have to do it before even everything. What? How to get this number then? You're getting number bigger than 10 to the power 5. So then you can get some value. Maybe 10 to the power 5 and let's say 10 to the power 5 plus 1. This is the number product of the numbers. Now what you did did to do it. That's why they are saying keep the number 10 to the power 5 till 10 to the power 5. Why don't I do this mod? Okay, I got this number. Listed 01, start 1. How do you keep wasted 0? It will be 1 only when you will get it. Could be. They start equals to 1. I don't know. Okay, I will do one thing. Start append start 0 steps. Then you will do this every time you are taking mod. Do I need this ns less than int? Okay. Okay, so if it is greater than and less than, no, no, it could be greater than and then also you have to wait until you are not getting. This is the, I'm not agreeing. I mean, whatever I, it's a, definitely I need to solve it again. Solve it again feels like not doing. Oh, banjo, why it's reading? Is anyone watching? No. Sit. I'm only the person who is studying. Solve it again feels like not doing uh, correctly. Uh, Looked the hint. Sorry if you hint and made plenty of mistakes. Forgotten or desperate to solve. Pancho desperate का spelling mistake. Desperate. What is desperate? Desperate. P. Despacito. Where is desperate? Here. I don't know. I never to solve and get the result. Very bad habit. It's a habit. When you are making bad habits, you have to recorrecting them is very difficult. Oh, this is a pretty famous algorithm. I heard the name of it. I never read about it, or maybe I read during my college, but it's bad. Either learn something fully or not learn. Because no matter whether you learned it in the past, if you can't remember, that means you will make same mistake again. You will visit the same thing again. Okay, so I know I heard the name Bellman Ford, and what is another Fried Voicel algorithm? I'm so sorry if I'm pronouncing them wrong. And another one is ah Dijkstra, 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 Dijkstra. What exactly we are doing in Dijkstra? We are using priority coup, and so let's learn about Bellman Ford algorithm. So is it first to get the shortest path? Literally, I need to watch the video because I want to learn it. I think I need to drink water. I just wanted to see if anyone is watching. Oh, bhai, Canadian algorithm. I think I learned the I know the Canadian algorithm. It's used for array. Uh, something is happening. I remember. I if I'll see the problem, I can get it. Whether can be solved using Saloni. Who is Saloni? Solving Cardinal algorithm template-wise lead code problems. See solving a code shift.
Like taking a long to understand a single problem. Like understood what you said. Right. Oh, this is a new
Placements.
books property.
Infosys preparation, Accenture, Wipro, MCAT.
Fine.
I will use my different ID. I'll chat. Just give me 2 minutes.
For me, I got books property. Okay, thanks for clearing this up for me. I got books property.
Hey,
People
I
do
will.
have to think about it while playing chess. People do have to think about it while playing chess. No kind of story. Chess is kind of scary. Are we done with this question? No kind of story. Are we done with this?
This is my
Picking
problem.
it is based on white square and black square. Okay, 3 modulus 2 is 1, 15 modulus 2. That's fine because the people can't move. Okay, I kind of understood this condition.
Java.
Okay.
Mer Java. Java, mer Java, but I won't go to Java. I hate it. Transition. Bro, it's crazy. I don't know why. Even I'm opening YouTube. I opened for other purpose, but don't know why. Why? Who is watching? I'm watching someone else. By the way, let's solve. No, I was in the another problem. Billman Ford. I need to watch the tutorial first. So editorial, tutorial, not editorial, tutorial, tutorial.
So in this video, we're going to learn about the Bellman-Ford
I'll
algorithm.
take
And this is
drink
again an
water.
algorithm which will help you to find the shortest path. Yes,
Hold on,
I
bro.
might be thinking, but Strego,
Okay, got the water.
we already know an algorithm like Dijkstra, which helps us to find the shortest path. How
Dijkstra.
is this different? It is the exact similar algorithm which will help you to find the shortest path from a source to all the other nodes. Yes, to all the other nodes. But the only difference is, if you remember the video of the Dijkstra algorithm fails when the graph has negative edges. Please remember, if the graph has negative edges, the Dijkstra algorithm will fail. And there was
Yeah, it
another
was
point,
repeating
if the
for
graph
me.
has negative cycle, the Dijkstra algorithm goes for a TLE, like it will keep on running, it will keep on running, keep on minimizing the distance, it keeps on running forever. So Dijkstra does not help you to detect negative cycle. So Bellman-Ford is an algorithm that helps you to detect, remember this, it helps you to detect negative cycles as well. That's the specialty about Bellman-Ford, and it is applicable, and it is applicable only in DG. What is DG? Directed graphs. Now you might be thinking, what if it's an undirected graph? And how do you apply Bellman-Ford algorithm to it? Very simple. Remember, this is how a directed edge looks like. So the edge weight will be 5. So there's an edge from 1 to 2, and the edge weight will cost you 5. But imagine if I give you an undirected graph and I say 1 to 2, and the edge weight is 5. So in order to implement Bellman-Ford, you need to convert this into something like 1. There's a directed edge from 1 to 2, which will cost you 5. And there's a directed edge from 2 to 1, which will cost you 5. So you just need to represent the undirected graph in form of a directed graph in order to implement the Bellman-Ford algorithm. The Bellman-Ford algorithm will only work if you are given a directed graph. Remember this. So if you're given an undirected graph, just change it to a directed graph by having two side edges with the same edge weights. That is how you can always implement Bellman-Ford for any of the questions. The only difference from Dijkstra is it helps you to detect negative cycles. What do you mean by negative cycles? Imagine I draw you a graph which goes from 1 to 2, 2 to 3, and 3 to 1, and the edge weight is -2, -1, and something like 2. So if I ask you the path weight, what will be the path weight? The path weight will be very simple. It will be -2, -1, +2. So -2 +2 will go, and the path weight is basically -1. So if you apply Dijkstra, it will keep on rotating, keep on encircling in the path, because the path reduces at every stage. So thereby Dijkstra will fall under the TLE loop for such an example. But when you talk about Bellman-Ford, Bellman-Ford is an algorithm specifically designed such that it will tell you that, hey, listen, this particular graph has a negative cycle. This is what you call as a negative cycle if a path weight is lesser than 0. If a graph has any path weight which is lesser than 0, then I can say that the graph has a negative cycle. Now let's try to implement the Bellman-Ford. Hey, listen,
Sorry.
very simple. It will be -2 negative cycles. What do you mean by negative cycles? Imagine I draw you a graph which goes from 1 to 2, 2 to 3, and 3 to 1, and the edge weight is -2, -1, and something like 2. So if I ask you the path weight, what will be the path weight? The path weight will be very simple. It will be -2, -1, +2. So -2 +2 will go, and the path weight is basically -1. So if you apply Dijkstra, it will keep on rotating, keep on encircling in the path, because the path reduces at every stage. So thereby Dijkstra will fall under the TLE loop for such an example. But when you talk about Bellman-Ford, Bellman-Ford is an algorithm specifically designed such that it will tell you that, hey, listen, this particular graph has a negative cycle. This is what you call as a negative cycle if a path weight is lesser than 0. If a graph has any path weight which is lesser than 0, then I can say that the graph has a negative cycle. Now let's try to implement the Bellman-Ford algorithm. So I will be taking this particular DG, which is the directed graph, in order to implement the Bellman-Ford algorithm. And we know that it is a single source shortest path algorithm. So the starting point is 0, and these are the edges given to you. So the edges will be given like U and V, which means there's an edge from 3 to 2 with an edge weight of 6. There's an edge from 5 to 3 with an edge weight of 1, which is very obvious. If you see, this is this particular edge, and if you look at 3 to 2, this is nothing but this particular edge. So all the edges are given to you. There's something very, very important to note down. Edges can be given in any particular order. Yes, edges can be in any order. Like, it's not necessary that you have to follow any particular order. If you carefully see, you can have 3 to 6 at the top, you can have it here, you can have it here, you can have it at the bottom. The edges can be jumbled, it can follow any order. What matters is you have to have all the edges of the directed graph. The order can be anything. Very, very important. Edges can be in any order. Now, what does Bellman-Ford state? The Bellman-Ford will state you have to relax all the edges. Remember this. Relax all. Very, very important. Relax all the edges n-1 times sequentially. Very, very important point. Now, what do you mean by relax? Why n-1? Everything you'll understand if you watch the video till the end. So what they're saying is relax all the edges n-1 times sequentially. Now, what is the definition of it?
I'll take pause. Relax all the edges n-1 time. So there are n nodes. What do I mean by relax all the edges n-1 time? Okay, let's see.
Relax, let me write that as well.
n-1. So if there are n nodes, there will be n-1 edges. Is it? No, it's not necessarily. There could be more than n-1. Suppose there are 3 nodes. If there is only single edge, but it could be, I think, 1, 2, 3, 4. So it could be this, 4. There are 4 edges and there are 4 nodes, 4, 5. So n into, for each n-1, n into n-1. Yeah, so n into n-1 edges. Can I pause? Relax all the edges n-1 times. Why?
So the definition of relax states if you have a distance array, and if the distance taken to reach u plus the edge weight that you require, for an example, you're standing at 5 and you want to go to 3, the edge weight is 1. So this is the edge weight that I'm talking about. So if the distance of u plus wt is lesser than, very, very important, is lesser than the distance of v, which means as of now, you're at 5, you're trying to go to 3 with a 1. So whatever distance you took to reach this u, which is 5, so basically distance of 5 plus this 1, if that is smaller than this, whatever you took to reach 3, then you got a better guy, similar to Dijkstra. So what you'll do is, you will simply go ahead and say, okay, I got a better guy. So I'll be like, distance v is equal to the new distance, which is distance u plus w. This is what I call as relaxation of edges. This will be done for n-1 times. What do you mean by n-1 times? If you go over here and look at the n over here is 6, because there are 0, 1, 2, 3, 4, 5, like zero-based indexing at nodes. So thereby n is 6. So you have to relax it for 5 times. 5 iteration of relaxations has to be done. Now, how to do it? Let's understand that. But before that, since you are calculating shortest path, what do you require? You require a distance array with everything initialized to infinity. So let's do that. So initially, when you initialize the distance array, the source will be marked as 0 and everything else will be marked as infinity because you haven't reached anywhere. So as of now, you know you're starting from here and that is always going to be taking a distance of 0, but you haven't reached something like 1, 2, 3, 4, 5. So what you do is you just initialize them with infinity. Now, how many iterations or how many relaxations you need to do? N minus 1. What is n? 6. So remember, you have to do 5 relaxation is what you need to do. Now, the first relaxation, let me explain you. If I say first relaxation, what you need to do is, now on the first iteration, what you'll do is, you'll go across the first edge, second edge, third edge, and so on to the last edge. You have to go across all the edges, and that is when you say first iteration is done. On the second iteration, you have to go across again, third iteration again, fourth iteration again, fifth iteration again. You have to keep on going for 5 times. Okay, so when I say first iteration, what does that mean? That's very, very simple. You have to perform this thing on every edge, one by one. That is what you call as one complete iteration. Okay, so the first iteration, what will happen? The relaxation of this edge will happen, then this. So let's do the relaxation of the first edge. Very simple. I know I'm starting like distance of 3. I will take 6 in order to reach the distance of 2 because from 3 to 2 is where I need to go and I'll take a 6. So what is 3? If you look at 3, the value of 3 is nothing but infinity. So if I haven't reached 3, is there a point in going ahead with 3? I haven't reached 3, so there's no point, right? So the relaxation of this edge is done. Next you go to this edge. It's like from 5 to 3. Cool, let's again do the relaxation. From 5, you take 1 and you reach 3, right? So can I say 5 is still infinity? So you haven't reached 5. So if you haven't reached 5, there's no point. Next is this one, which is 0 to 1. So you can start from 0, you will take 5 and you will reach 1. So when you say distance of 0, it says, yes, I have reached myself. It's a 0 distance because I'm the source. Plus, I'll take another 5. And I'll reach the 1, which was previously reached with infinity means not reached. So I've got 5. So I can go and update this to 5. So on relaxation, I update one of the nodes to 5. Perfect. Next is this guy which has to be relaxed, which is distance of 1 minus 3 lesser than distance of 5. Wait.
1 minute. Distance of 0 plus 5 less than distance of 1. So distance of 1 is infinity. So if the new distance is less than the existing distance, then you are updating. Okay, so definitely every time in every relaxation it will relax only one edge because all other will be infinite at starting. Oh, no, it could be, okay, for example, it could be from 0 to 1 you are reaching, 0 to uh, 5 you are reaching, 0 to another node you are reaching. So all the nodes that are same level will be relaxed. Correct. And in the next level, in the next layer, basically, no, not next layer, but in the next iteration, again you will starting for each node. You will check if you are able to get better result, then you will relax all the edges again.
Very, very important. Distance of 1 minus 3 lesser than distance of 5. So if you carefully see, we have a 1 here. Right? Do you see? We have a 1 here. So how much has 1 taken as of now? 1 has taken a 5. So it's like 5 minus 3 lesser than distance of 5, which is infinity. So 2 lesser than infinity. So I can reach 5 in distance of 2. So go and update this with a distance of 2. And I can say the relaxation of this particular edge has been done. Next is this guy. So let's quickly relax this as well. This is nothing but you can write distance of 1 minus 2 lesser than distance of 2. Again, what is distance of 1? If you carefully see, it's nothing but 5. 5 minus 2 is 3, which is lesser than infinity. So you get 3. So go and update this to 3. Perfect. Done. Next, you will go across and do this particular iteration. So this is nothing but 3. So you can again write distance of 3 minus 2 again lesser than distance of 4. That's what you can easily write. And can I say, if you, why is this coming up again and again? Wait. So what I can say is, what is distance of 3? Can I see this? That distance of 3 is still not infinity, so this will not be done. Next is the last edge, which has to be relaxed. Let's quickly relax the last edge, which is nothing but distance of 2 plus 3 lesser than distance of 4. What is distance of 2? Let's see. It's 3. So 3 plus 3 is 6. What is 4?
4 is
infinity. So can I say this will be updated to 6? So what I can say is, the first iteration has been completed. And the first iteration, we have got the updated distance values. Okay, now you have to again do it, which is the second iteration. At the second iteration, what you'll do? You'll again start from the first. Now what is distance of 3? Infinity, not reached. What is distance of 5? This time you will find 5 has been reached with the distance of 2. Why did you find? Because in the first iteration when you went, 5 was updated somewhere here. And now again when you come back and restart, that 5 value which you updated here will be in use here. So what is the 5's value? 2 plus 1, which is 3 lesser than infinity. So this will go as 3. Go across and update 3 as 3. Perfect. Next one, this one. What's the value of 0? 0. So 0 plus 5 lesser than 1, it's still 5, not to be done. What is 1? 5. 5 minus 3 is still 2, which is lesser than, not lesser, so not to be done. Again, let's check out this. What is 1? 5 minus 2, which is 3, which is still not lesser. What is distance of 3 this time? This time distance of 3 has been computed. What is distance of 3 this time? 3
2.
minus 2, which is 1, says 4. Is it lesser than 4? Yes, because 4 is 6. So if 4 is, if you see
Wait
4
a
is
minute,
6.
bro.
Yes, because 4 is 6. Says
Distance
4.
of 3 is 2. Sorry. Distance of 3 is 3. Here is the index and here is the value.
Is it lesser than 4? Yes, because 4 is 6. So if 4 is, if you see 4 is 6, what I'll do is I'll say distance of 3 was 3 minus 2 is 1, which is better than the current distance. So I'll go and update this to 1. Very simple, because I started with 3 and I'll take a minus 2 distance in order to reach this guy. Again, the last guy is this, which is nothing but 3 plus 3, again 6, which is not better than this. So I can say the second iteration is also done. Similarly, you will do the third, fourth, and fifth. Basically, again ramp, again ramp, again ramp. And once you've done this particular distance array will be storing all your shortest distance. Yes, it will be storing all your shortest distance. And if you carefully look at this, it does not have a negative cycle. It does have negative edges, which is allowed, but it does not have a negative cycle. So ultimately, after all the 5 iterations or n minus 1 iterations, your distance array will be giving you the shortest path from the source 0 to all other nodes. Remember this, which will be stored in this distance array. Now, a couple of questions. Why n minus 1 iterations? That's the first question. And the second question will be definitely how to detect negative cycles. What if the graph has negative cycles? How will I know about that? So, because the entire algorithm is pretty much similar to Dijkstra, because this portion is similar to Dijkstra. The only thing that we are doing is we are just doing n minus 1 iteration. So obviously, I want to know n minus 1 iteration because the thought process is kind of clear. But why n minus 1 is my question. The thought process must be clear. Why? Because we just move ahead and this guy was updated. This updated 1. Then with the help of the 1, I got updated 5. Then again, when I came back, with the help of 5, I updated 3. Then again, when I went with the help of 3, I updated 4. And it went on moving. So eventually, everyone was getting updated on all the iterations ultimately. But how did I know that on n minus 1 iterations, I will get my answer? That's my question. Because what if I would have done 2 iterations? What if I would have done 3 iterations? The question still lies, why exactly n minus 1 iteration has been done? So let's understand that as of now. So in order to understand the intuition, or why n minus 1, because that is the critical question here. Because we have understood the thought process. We knew 1 helped me to compute, because we knew 0 was the source which helped me to compute 1. 1 helped me to compute 5 and 2. And similarly, 2 helped me to compute 4, right? And when I came back, since I had computed 5, this 5 helped me to compute 3, and eventually this 3 helped me to compute 4, and so on. It will just go on this loop.
I think the main reason behind it would be simply imagine there are all the edges in such a way that let's take. I mean, just let me give my thought. What exactly it could be? What we're doing here, bro? Just solving the DSA problem. Techno Wallach. I just solving graph problems and watching tutorials if needed. If some new algorithm, so I'm following the take Q forward, or you can say Strivers uh, shit. Game over? No, it started only. It's not over. My dates are bigger. I won't laugh. Sorry. Yeah. So I will do one thing. Okay. So suppose there is one is from 0 to 1 and 1 to 2 and 2 to 3. So every time what exactly we are doing, suppose we have the value of 0, it will take 0. Then let's say 1, 3, 5, 4. So 1, 3, 4, and imagine I'm doing from here to here, I'm reaching here. I just want to understand why n minus 1 iteration he is gonna tell, but before that I'm just giving a thought what could be the reason. So we are using Bellman Ford. To be honest, I don't know why and how they get these kinds of algorithms. Maybe they are doing research on it. They did research on it. Okay, so in the first iteration, what is going to happen? So there are races like 0 to 1 and with the weight of 1, 0, and another is 1 to 3. Sorry, 1 to 2 2. Okay, 2 and weight of 3, and another one is 2 to 3, weight of 4. So in the start is in the start you are just checking u, uh, distance of u plus weight is less than distance of v, and at the starting everything will be infinite, so distance will be 0, infinite for 1, infinite for 2, infinite for 3. Okay, so what exactly we did here in the distance of 0 0 plus weight 1 is less than this, so you will do okay, yeah. So 0 plus 1, I will do in such a way, 0 plus 1 is less than infinity, yeah, true. So 0 plus 1, that is 2. So what you will do, basically you will update the distance for this u to v reaching it, so you will make it 1 in the second iteration. Now here you will check 1 to 2. Oh, okay, okay, okay. It will be done in one step only, because every time you are going to get. But let's thought about it. Hmm. It could be in any order, right? So let's change the order. I mean, if the aces are in the order, symmetrical order, 0 to 1, 1 to 2, so you will say, okay, you will get the result in this one. You will get the result because this depends on this, and you will get the result in one iteration. One iteration. But what if, imagine these are jumbled, and basically there will be some ace from source to any node, and you are able to in that iteration, in the first iteration you are able to solve only one node, so one new node, and same is happening in the next one. I don't know example. So every time you are resolving a node, so every time you are solving n, so there are total n nodes, correct? And out of that what you are getting, every time just you are able to get the result for one node. So you are making slow progress, maybe you just got the result for the 0 to 1 in a one iteration, the 0 nodes that are connected to the source, and in the second one you are just progressing further here to here, then in the third here. So there are n nodes, so you need n minus 1 iteration to finish all the nodes. But that is okay. But how can we be sure, sure that the distance will be shortest? The distance, yeah, this is the main question, will be shortest, because, sorry, here I can see one thing, why this is still there. I mean, yeah, function if I think that will work. Crazy. Stop it, bro. It's gone. So, okay, let's do one thing. So, every time, what exactly we are doing? We are basically trying to reach the nodes from source to, let's say, 1, 2, and 3. So, we reach to these node. So, we'll get some distance for these this one, this one, this one. And now, suppose in the first iteration we resolve these nodes that are directly connected to it, or the nodes that are reachable in the same iteration that are coming after the source nodes. Let's say there is another node, and this is okay. Let's say 4, 5, and 6, and these nodes are after it. Let's say 0 to 1, and 0 to 2, 0 to 3, 0 to 4, no, 1 to 4, 1 to 5, 1 to 6. So these are the nodes that are coming after it. So this can be resolved because these are dependent nodes are resolved, and after that you can resolve these nodes. So you will do that in one iteration. In the second iteration, what exactly going to happen? In the second iteration, you will update whatever you got the minimum. Might be like here you got some distance, and after that you got some distance from here, or maybe uh, for 0 to 1 you will get one distance, right, in each iteration. And in the next iteration, no, I need to watch. I need to watch the video.
Thought process is clear, but why n minus 1 is still the question. Let's understand this with this particular directed graph. So in this directed graph, if you remember, while explaining, I did tell you edges can be in any order. Edges can be in any particular order is what I always stated, right? So imagine I give you the edges in this particular order. So how many nodes are there? The number of nodes are 5. So how many iterations will we have? We will have 1, 2, 3, and 4 iterations because edges are 5. So I have to do n minus 1, which is 4 iterations, correct? So now what I'll do is I will start off with the distance array. So let's quickly have the distance array. So again, to ease of understanding, I have kept 0 as the source and made it a distance of 0. Okay. Now let's do the iterations. So the first iteration states this is the first edge. So it states, okay, distance of 3 plus 1, are you lesser than distance of 4? And it's like distance of 3 is still infinite. No. Go to the next one and says distance of 2 plus 1, are you lesser than 3? And I see distance of 2 is still infinity. No. Next one will be distance of 1 plus 1 is lesser than distance of 2. I'm like 1 is still infinity. No. Next, I will like distance of 0 plus 1 is lesser than distance of 1. I'm like, wait, 0 is 0 plus 1 is lesser than infinity. So 1 goes as 1. So go and update 1 as 1. Perfect. So in one iteration, at the end of the day, this one was updated. So first iteration, done. Okay. Now let's talk about the next iteration. Next iteration, what is 3? Infinity. Next iteration, what is 2? Infinity. Next iteration, what is 1? 1. So 1 plus 1, 2. So this will be updated to 2. So let's update it to 2. Next, 0 plus 1, not to be done. So second iteration done. So did you see what happened? In the first iteration, the 0 got the value of 1. In the next iteration, since you had the value of 1, that one helped you to get 2. So the third iteration, what will happen? Come on, what will happen? Think. Yes, you're correct. Yes, you're correct. The third iteration, we don't have 3. But the second iteration gave me 2. When I go to relax the next edge, this 2, who has the value of 2 plus 1, will go ahead and update 3. So 3 will be updated to 3. Perfect. Amazing. So I see this is done. Next, no more updates, no more relaxation. Third iteration done. Third iteration. Now, what happened in the first? 0 updated 1. What happened in the second? 1 updated 2. What happened in the third? 2 updated 3. Now what will happen in the fourth? What will happen in the fourth? Yes.
We will update
the 3 that you got will help you to update 4. So what did you get? 3. It says 3 plus 1, 4. So this will go as 4. So ultimately on 4 iterations. When I say ultimately on 4 iterations, the distance array is ready. And this is your shortest path. Yes. This is your shortest path. Can I see this? I can. So therefore, did you understand why n minus 1? Because of the worst case, you can have the guy at the bottom who will give you this. Then this will give you this. And then this will give you this. And then this will give you this. That is why n minus 1. That is why n minus 1. Yes. I hope that's clear. You find a lot of content over YouTube, but no one will say you why n minus 1. They'll be like, n minus 1, let's do it. We got the answer, code it, and that's it. This is very important. The thought process, the intuition, and the clarity about an algorithm is very, very, very important. Now, the question is, how to detect negatives? Again, thought process. Since I knew, negative cycle means if I keep on, because this will give you minus 1. Again, if I rotate, it will give you another minus 1. If I rotate another minus 1, on every rotation, you are decreasing the path value by minus 1. So what will happen if there is a negative cycle? So what will happen is, if there was 5 iterations, if you do the 6th iteration, the values will still reduce. On nth iteration, the relaxation will be done. And if the distance array gets updated, because we have proved that at max we will be requiring n minus 1 iterations have proved. But even after that, if I require on that iteration, if I do a relaxation, and even if I see distance gets reduced, I will be right. Negative cycle exists because I know at n minus 1 iterations, I should have gotten my answer. But if at the nth iteration, there's still a reduction, it means we are running in the loop. We're running in the loop. That's where the distances are reducing. So both the questions answer. So it's now time to code it up. So I hope you understood the entire algorithm. Now it's time to code it up. So as usual, I'll be coding the C++ on the right, and you can figure out the exact similar Java solution on the left. So given a weighted, directed, and a connected graph of V vertices and edges, find the shortest distance of all the vertex from the source. So that
I want to talk to ChatGPT now. ChatGPT, come on, wake up. Yo, time to help me. Hi GPT. Actually, I'm learning Bellman-Ford graph algorithm, but I have a confusion or I need clarification on the thought process behind the algorithm because I got why are we doing n minus one iterations, uh, so or we can say n minus one iteration to relax all the edges. And the reason behind it is simply in worst case if the order of edges is in a such a way that every time you are able to relax only one edge or you are able to get progress further or progress, basically you are able to derive the distance for one node. So that's why you need at max n minus one time to relax or to get the distance for n nodes. But the doubt is, how can we be sure that we will get the shortest distance for each node? Yes, that is actually the core idea behind Bellman Code. Your understanding of why we do n minus one iterations is basically correct. Correct. The missing piece is why does relaxing every is n minus one time guarantee that we distances we end up with are the shortest distances. Very intuitive if we think in terms of number of edges in the shortest path. Number of edges in the shortest path. The key theorem. Assume there are no negative weight cycles reachable from the shore. Oh, okay. My will it impact my imagine? Okay, there are actually no. The key theorem, and this is actually the core idea behind Bellman Ford. Your understanding of what this when the missing piece is why does relaxing every is n minus one times guarantee that the distances we need no we end up with are the shortest distances. The answer becomes very intuitive if we think in terms of number of edges in the shortest path. Number of edges in the shortest path. Key theorem. Assume there are no negative weight cycles. No negative weight cycles reachable from the source. For any node V, its shortest path from the source can contain at most n minus one edges. Any node V for any node V can contain at most n minus one edges. How? 1 minute. I have a confusion here itself. For any note, where is my pencil? Otherwise, plan will be cancelled. Hi, bro. Good one. You go and sleep. I'm not gonna sleep right now. Why are you waking till 3:30? Bro, am I looking like Modi? Really? Maybe you go to doctor and have a checkup of your eyes. Camera angle? What's wrong with camera angle, bro? I'm just using face cam. Bro, maybe you are watching so many reels. I'm not sure if you are referring any reel. Uh, because I have heard. Maybe I just watched on YouTube Shorts. Our Prime Minister started giving the message using Insta. So maybe yeah. Oh, you are joking. Cool, bro. Hmm. What's your name? How do you pronounce it? Mashu? Mashau? Mashau. Yeah, looking like Modi. Mr. Modi. Sorry. Okay, let me go through to theorem. Hmm. So, okay. First, I wanted to understand what's the reasoning behind. Hmm. Assume there are no negative weight cycles reachable from the source. Reachable from the source. Negative weight cycles for any node V. Its shortest path from the source can contain at most n minus 1 edges. Why? Oh, yeah, it's explaining. Suppose the shortest path had n or more edges. There are only n vertices. So by the oh man, Chup is an old principle. I forgot it. I heard about it. So by the Pisanol principle, some vertex must appear twice. For sure, definitely. If you are going from A to B, n minus one, B to C, like distinct edges you are covering. So basically, there will be n minus one edges between n nodes. And if you are repeating some edges, then only it will be appearing twice. Nodes are appearing twice. A vertex, you whatever you say. That means the path contains a cycle. If the cycle has positive weight, okay, when there is no reachable negative cycle, a shortest path can always be negative weight. There is negative cycle, meaning no finite shortest path exists. Okay, got it. Positive weight, removing it makes path shorter. So that means okay. So there are two paths from let's say A to D, A to C. How to A to C? Let's take A to C. There is a path. Let's say D to B. Suppose D to B or D to C. There is a path, and what exactly we are doing? So there is a path. Now you will choose only one which is having smaller distance. So okay, now comes the important connection to the iterations. Think of each Billman Ford iteration as how many edges of the shortest path am I guaranteed to have processed. Suppose the actual shortest path is S A B C. Initially infinite. After our first iteration, we can discover it. Second, we got it. But what about the A's order? This is subtle part you are asking about. Suppose the edges are processed in a terrible order. Every iteration are increasing. No. The beautiful way to think about Bellman Ford. Imagine every iteration as increasing the maximum path length. So length you are in considering. Iteration one shortest path using less than one edges, less than two edges. Shortest path using one edges. 2, 3, and minus 1. Not literally in every implementation because in place relaxation can propagate farther within the same path. This is the correct intuition. Therefore, shortest path contains at most n minus variable. Oh, okay. This one intuition is, I think, best one I can get from. So, let's say there is a node 0 to 1. I mean, so you are relaxing all the edges that are accessible from source, and didn't get. Good night, bro. Sorry, I was not checking the chat. Are you feeling sleepy? So, okay. Not literary in every implementation because in place relaxation can propagate farther within the same path depending on age order, but this is the correctness intuition. Therefore, shortest path after n minus 1 round, every valid shortest path should already be settled. So we do not do one extra round. If you can still improve some distances or distance, that means there is a cycle. Negative is cycle. We aren't really counting vertices. We are guaranteeing that every shortest path has at most n minus 1 edges. That's correct. There will be n minus 1 edges. I still feel like I have a missing part of it. I have a confusion somewhere. How many problems I solved? One only. Yeah, one only. So another problem is still pending. Bellman Ford 0 to 1, 0 to 2. Imagine you relaxed both of the edges and suppose from somewhere 3 you are able to reach to 2 and you are in each iteration relaxing some edges. So there will be n minus 1 edges in a shortest path. That is okay. So what exactly I'm doing in each iteration? I am relaxing one edge, relaxing one edge, or all the accessible edges. Hey GPT, actually I got the idea why earlier I was thinking in a way that we have n nodes, so to reach to each node and update its distance we need n minus 1 iteration at max. But you explained that there could be at max n minus 1 edges to find a shortest path, or it could be like we can reach from this node to another source to distance in less than n minus 1 nodes. That is also possible. So at max n minus 1 edges, that's why we are uh, performing n minus 1 iteration to resolve or relax each edge. But still I have a confusion. How can we be sure that in n minus 1 iteration will get the shortest path. Can you give me the correct reason or intuition how to get it exactly? Because I'm still not able to grasp it fully. Grasp it fully. I'm full. I think they should build some bots who can teach us. Not the bots, but some robots. I think, yes, I think I see exactly where the remaining confusion is. We are not doing n minus 1 iteration because we have n minus 1 edges to relax. Oh, again, I did something wrong. We do n minus 1 iteration because any shortest path can be represented using at most n minus 1 edges. Forget the graph for a moment. Imagine the shortest path has 4 edges. Yes. Now imagine that somehow we know distance of 0. How can we discover the distance to d? The missing puzzle is this one only. A to B, B to C, C to D. In each iteration, you are relaxing eyes. One or more than one. It could be that you have relaxed all this. I'm missing something. Still have confusion. Suppose here we have three nodes. So we need ten, 5, 3. Either someone hasn't reached, or if reached, then you are updating. Otherwise, no one reached. Ah, I got it. I mean, at least I got some. Perfect. Far better than what I was assuming. So let's solve it now. Where is the bellman, bro? Come on. Let me take a laptop in my lap. Tired, bro. Today I'm planning to. After it, I will do revision. How am I looking if I'm keeping laptop in my lap? Hey guys, anyone watching? Sorry, I'm not even. I took a lot of time. 3:57. That's why nowadays I'm like not like, but I'm waking up around 1 o'clock, 1 o'clock or 2 o'clock. Very bad lifestyle. Lifestyle. So what exactly we need to do? What is the problem statement? Given a weighted and directed graph of v vertices and edges, E edges. An edge is represented AIBI VI, meaning there is an directed edge from AI to BI having weights WI. Find the shortest distance of all the vertices from sources. If the vertex can't be reached from it, then mark distance 10 to the power 9. So okay. So max distance is nothing but 10 power 9. Okay. Now for each distance we will mark distance will be v ways. So max distance for underscore, basically we are marking in a range. V are the nodes. Now hmm, maybe what not maybe, but this is the one. And now I need to mark distances of s. S capital S equals to 0. For the source node you don't need to uh, travel any distance, it's like at the 0 itself. And now there are edges, right? For uh, I will use underscore in range v minus 1 times. And what I'll do simply, for edge edges edge in edge, I got the edge. It looks like awkward. How am I sitting right now? How I am sitting right now. Sorry. So I got the edge, and an edge contains three things: U, V, AI, BI, WI. Shall I call AI equals to no AI and BI WI is equals to edge. So we got EDGE. So we got these values. Now I need to just make AI to BI I want to reach. And what is the condition? If AI, so distance of AI plus, okay, I'll do one thing. If distances of AI less than max distance, then only do need to process. Then if okay, I can do it in one go. And distance of AI plus WI is less than distances of BI, then you can relax this and you can mark the value distances of BI is equals to nothing but easy peasy. This is one of the simplest algorithm I would say. And at the end, oh fuck, they have given. So this is for this these many times. Has negative. Bro, either use a snake case or camel case. Just use one. Negative cycle equals to false. And I will do one more time iteration. One more shot for underscore in no, I don't need that. I can just directly do this. So here, if anywhere you are getting this, that means uh, has negative cycle true and break, because that means somewhere you still are able to relax the edges to check if uh, distances of vertices are still relaxing, still uh, minimizing, and at the end, if has negative cycle, then what you'll do? Alright, and simply minus 1 into, I would say, v times L's radon raise distances. It so what's the problem? It seems like something is wrong here itself. Oh shit! I did something boolean here, and seems like because of this only. You were the shadow of my light, like girl. What do you want? And yes, you want what? Minus one or minus one directly? कोई ना. No problem. Is the big problem. So said I. Let's stop the graph. Graph is done, bro. Graph done. Hi. Anyone watching? No watching. I will do one thing. I will watch my own. I- Anyone watching? I'm watching. No watching. Hey guys. I will do one thing. I will watch my own. Anyone watching? I'm watching. I'm watching, so I'm watching. Hey guys. This is the biggest problem. Oh, I forgot to do something. I'll take break in the sense I will take little break, then I will start better. Okay, so welcome back. Yeah, so let's begin again. I mean, so what's plan? Bellman Ford. Now take you forward again, and I will do DV problems. To be honest, I just want to sit relaxed. Fucking crazy. I don't know. Just get out. I just want to sit somewhere. I don't know how. Camera angle with high and top looks odd. No, I will look out in this way. Oh fuck. God. सुनियो सुनियो ना तेरा touched. Let's begin, bro. Guys, I need to solve now DP. So DP, I need to revise basically. I'm not sure. So I was solving. I have started from climbing stairs, frog jump. Or shall I do it random? Is there any option? Random problem. Yeah, let's do random problems. Oh, very good. Wait a minute. All problems. I think it says picking random problem. I don't know how it's picking, but it's okay. Let me just reset it first. So maximum sum of non-adjacent elements. Given an integer array, nums of size n, return the maximum sum possible using the elements of nums such that. Okay, I'll do one thing. Start now. Given an integer array of size n, return the maximum sum possible using the elements of nums such that no two elements taken are adjacent in nums. For example, 1 to 3. So here you can 1 to 4. So you can use 1 and 4 for. So why do I feel like it's just you have to start to string? Is there any other possibility? 1, 2, 4, 6 or 1. Okay, okay, okay. 2 and 9 you can take 2, 9, 11, and you can take out 2, 4, 1 and 9, 10, 2 and 9, 11. Okay, so there are multiple possibilities. Wonderful. So every element has two options. Either you can take it, either you cannot take it into the part. Okay. So for example, one has option take or not take, two has option take or not take, four has option take or not take. So and yeah, you can do it using recursion. How many options? No, I won't check because this is revision part. So I want to do it quickly. First option is simply start from first item, and every time you have two choices, either select it or not select it. If you are not selecting, I mean, yeah, then you can say I need to pass the last index, right? Then only I'll get to know whether last one taken. If you take the next element, you will say not take. So it's going to, I will write it first. Where, here. What I'll do, I'm looking off, I'm keeping it in one of my hand. So what I'll do, for God's sake, I will do one thing. This is our question where we have an array. I need to set it somewhere. We have array and we want to do some perform operations. So every time you have two options, like every for element 1, 4, 6, 9, let's say. Every item has two options. Choices: take, not take, and its decision. First, suppose next item's decision depends on it. If you took, then you cannot take adjacent element. If you haven't took it, then you can take it or not take it. It's up to you. So you always have choices, and the next choice depends on the previous choice what you took. So what can I do? Suppose you are at uh, first element. You are at a starting, so you are at zeroth index. You can say this is zeroth index, this is first, this is second, this is third. So you are at zero. So now you will say take, because at starting you can say there isn't anything. So you have false. Now, that means you haven't took the last element. So now you have option take. If you are taking, then you will pass one and true. If you are not taking, then you will pass one and false. But here now you reach to 2. If you it is true, then definitely you don't have this option take. You have only option uh, 2 and false. Here you have options, two options. One was false, so you have a liability to take true, and you have a liability to take false. Still you are not taking. Now you can see here this part is repeating here and here. So you are performing the same operation again and again. That's why in this type of problems we have to use DP, dynamic programming problem. Basically we can use memoization. Actually, most of the time whenever I'm solving, it comes first into my mind like, okay, I can use a recursion. Then we can jump into the uh, tabular approach. And so what can I do? Simply I will pass these two things. What are the values and what could be with the value? True, false, true, false. So I will start from here. And what could be the last value? Okay, suppose you are at the end. I equals to n minus 1. Base condition we need to find out, right? If I is in minus 1, okay, then what you will get? Or even forget about I n minus 1. Let's say if you are getting out of I n equals to n minus 1, I became greater than index. What does it mean? Will you get any profit? No, you will return 0. Correct, that is the okay. This way when you can take base condition. When you are out of the elements, then you won't get, if you are irrespective you are calling, but you will get 0 only. You cannot get any profit. And for all other options you will say okay, take, not take, take, not take, that way. So it's a very simple problem, and we are going to solve it using first memoization approach. Then I will uh, follow the another approach that is that is called tabulation approach. Top down DP, whatever say, bottom up, top down. So here first I will define a function that is I used solve always, so going to use same index. That will be index. I'm calling it full name index and uh, taken. So taken means it's a flag where you have taken last taken. It's a very bad name. Is taken. Is last taken. Let's take some descriptive name. Earlier used to take any name and solve. So better I will use is last taken. So what I'll do. So if let's say base, if index, okay, how to get it? I need to take other variables as well. That is nums, and I will take n because I don't want to calculate every time n. Otherwise, it will take time. Number of. By the way, I just wanted to see one more thing. Where is it? Where is the editor? Oh, okay. Let's forget about it now. Maybe I'll do one thing. Resume. Keep it as it is. I just want to see uh, time complexity of len in Python. Order of n should be fuck tangents. Oh, okay, okay, okay. Then I don't need to worry about it. Even I don't need to take another unnecessary variable. So if index greater than len of nums len, then you will say greater than or equals to even return 0. Else simply first I'm writing without memoization, then I will solve it using memoization because it's one step only. Okay. Then simply what you will do, you have two options. If is last taken, then simply you will say if the last one value is taken, then you can say simply return self dot solve. Okay, okay, I will do one thing. So I will use simple approach. Take uh, equals to 0, not take equals to 0. Both are the if is last taken. If last value is taken, then you cannot take it. So not take only will be going to use self dot. You will say solve, and here you will give index plus 1, and here don't forget to add the weight of nums of I. If last taken, so you will say 0 plus, because you cannot take this value, right? Index plus 1 and is last taken, so I will make it false, and nums you will pass. This is one thing. Else, that means you have both options. So take, if you are taking, then uh, nums of weight of this item. I don't know why I'm using weight, calling it waste. What is this the value value? number value. So nums of index you are considering it plus self dot solve and index plus 1 false will make true. Last value you took in nums. You are taking this value. So last if not taken, else are you have not take also. So you can say nums of index you are not taking, so 0 plus self dot solve. I think it will be same. Something is repetitive, right? That's why we don't need to this do this. I just want to optimize it. If not is taken, is last taken, then you will say take will be this value. Return max of take not take. Yes, this will give definitely TLE. Return self dot solve. Here you will give index, that means 0, and false at starting. You haven't taken anything, right? And nums will remain nums. But you will get TLE. Yes, you are repeating the same stuff again and again. I'm expecting TLE. Yeah, that's pretty cool. Now just one quick change here. You will create a memoized array where you will store. If some value you already calculated, you don't need to recalculate it. So I will say mem of size. Let's do it. So -1 I'm keeping everything for underscore in a range len of nums. So you got this. So for each item you are keeping and you are providing mem. Okay. And what exactly you are doing? If mem of index greater than or equals to 0, return mem of index. You don't want to recalculate the same again. Otherwise, you will say mem of index will be uh, max of take not take, and here you can return simply, or you can call that mem of index. I had a lot of doubts in the past, like okay, I need to store it somewhere. Maybe I just so okay. I forgot one thing here. Mem- Memory. Wow. Oh shit. I made one mistake. Hmm. Hope. What's wrong? Hey, what's wrong with it? Num's length. Hmm, got it. Every time you have two options, not only one will work. It need two things. Whenever you are passing this value, as well as you are passing whether it's taken or not taken. So I need to 2D array. So I will say minus 1, 0 will represent 2, and 1 will represent false. I will use one thing. 5 then 3 int of true. Fuck. Int of false 0. God. It's last taken. Mhm. Oh shit, I'm doing lot of mistakes. Hmm. Unsupported operand type is for types for plus int and list. Something's wrong here itself. What is the issue here? It's very simple problem, bro. I take how much time I take? Crazy? Something is wrong here. It is not take. Mem of index. Okay, okay, okay. First thing, do one thing. Flag. Set. But now this is one option. Another is we need to use table, table tennis, table tennis. So what I'll do simply, let's do let's draw it. I'm going to do one thing. Now we have two things, right? So I remember or not, we will draw a table. So what exactly we were doing in this, in the top down approach? What was it? Top down, bottom up approach. We were starting from zero to. Sometimes I get confused about top down, whether I call it or bottom up, guys. Should I call it? Why do I create it? First thing, we need two very no, I will tell like in such a way. I have to explain properly. So what I'll do, we have two things, right? Index and the value, a flag, you can say. Index and flag. So index represents which item you are processing in the array. 0, 1, 2, and so on. Flag represents whether you are processing as a taken or not taken. It will help to another item. 0, 1, not take, not yes. What a no yes. So I will say 0. These are the basically index. First item, second item, third item, fourth item, and so on. How many items are? So last item has, suppose there is only one item. So you have only two options. What? You can either you can take or not take. If you will take, then you will get benefit of this item. So it will be like if you are taking, then value will be something here. Correct. Value will be let's say x value will be here, and here will be 0. Now when you are moving to this item, you have two options. I mean, it depends on this. So if you are not here, imagine this is the item where you are. So you are at second item, or you can say ith ith index. So if you are at ith, you have two options: take or not take. Imagine now if the flag is take, correct. If the flag is take, so what will be the condition? If it is take, then you will take this item, and in the next step you will not take another item, you won't take. So suppose here you are taking, if the flag is no, that means the last item that you took, I mean, imagine you are here and you haven't took the last item, so flag will be no. And because of that, you can say here you can take or not take. So you can say here it will be max of next, the weight of this item, take and not take, take, not take. Okay, next, next. So this is the condition, and here you when you are taking, so w you will add. So this is a condition. Hmm. And if you are not taking simply, what does it mean? If you are discarding it, so you won't get it. And now you will say another option, that when you are not taking, then what will be the flag that you will call? If you are not taking, then you will call, okay, not take. So next, and index will be next index plus one, and you are going to call, okay, not take. Flag is last, flag is not take. So not take means this one, no part will come. So such a way we need to build. I feel like I'm not explaining it correctly. Wait, let me try first. It's a very simple problem, but I took 45. I have to speed up. Table will be something like, or I will call it TP minus one comma minus one, and oh no, I will keep 00 for you. Think for underscore in range. You can say len of nums. Okay, perfect. Now you will start building it. So first one is not take. So okay, one thing let's do. First thing, last element will be filled. So even you can start from bottom, top to bottom, because you had for zeroth index you have two options. For first index you can say, but it's not intuitive, to be honest, because every time when you are calling, the next will be called, not the previous one. So yeah, it's like you are building from bottom to up top. So for the last, I will say dp of minus one. That means last will be equals to 0 if you are not taking, and if you are taking, it will be, hmm, sorry, flag will depends, flag decides, like, if not take, if the last one was not take, then you can take it, so you will mark it as a uh, nums of uh, minus one, you can say, else you will mark it as 0, you are not taking. If you took it, then okay. Now for uh, I in range, so there are total len. I just need to do one thing, n equals to len of nums. So n I in range, so you will start from n minus 2 to minus 1 minus 1. And what exactly you are going to do? So every time you have two options. Okay, you have two options: take equals to 0, not take equals to 0. And if it is first one, if take, so what will you update? If the last flag Last one was basically 0. 0 means uh, not taken. So now you have two options you can take. So you can make, if last, I'm confused when I'm writing this, so it's very obvious. What I do? Oh god, I'm making such a repeating the same mistakes again. And so okay, 1 minute. Let me recall. Uh, Take, not take. Fuck. 0 represents when the last value was 0 represents last value was take, not take. So not take last value was false. You haven't took the last value. So there now, okay. So you can say dp of I of 0 will be max of take, take and not take, and dp of I comma 1, that means last value was taken, so it will be simply not take, because you cannot take it. And simply take, how you will calculate? Take means you are taking this value. So if you are taking this value, so you will say dp of I plus 1, and you took this. Zero. One. I have a confusion here. Suppose here you are taking this item in this field. Take. Then what you will call in the next? I got confused. Let's start from starting. Fuck man. Repeating the mistakes very bad. When you are at zeroth index, last will be false. So you will mark 0. When you are at here, if you are taking this item, that means in the next item you will call simply for the next, it will be 1. And if you are not taking this, then next one will be like last one was not take 0. So this is the one condition. And when you are calling it, so DPI and 0. 0 means you are the last value was uh, not take. So you have option take and or not take. One last value was one take. Oh, I think my thought process is very bad here. So DP of at starting, what you will say? 0. And what will be the value? Not take, so 0 0. Very bad. Suppose there is one element only, so you have last one was take, last one was 0. So not take, then you took it. And last one was take, you cannot take it. Where it stopped working? I thought I will quickly solve it. Last one was take. It's memorization fucking. Only I solved it using memorization. Oh, crazy. What is the missing piece here? It is in. I will do one thing. Print dp. Who will add this numsa file? जो कितने गलत है Okay, so another problem 517. Let me take a break. Or let me stop. I will start in. I feel it's not a weekly grind. Pancho, I'm able to do only one problem set. I will take break. I will off this time. I will start again once I will feel what I'll feel. Nothing. Bye bye. Good.